Hi, good morning to all of you. I hope you are still doing quite well today, and welcome to day two of the IIDA Summit, the IIDA, that is the Indian Interior Design and Architecture Summit, organized by the Architect's Diary and powered by Blended. My name is Benita Ghoshal, and I am the editor in chief of the East India Perspective. And just like yesterday for Screen One, today also I will be the host for Screen One. So welcoming you all to day two, as we actually already have begun day two with quite a banging start with such an amazing video by Winnie Mars about what's next. I'm pretty sure that all our creative and innovative juices have started flowing regarding what can be the future of our cities and what kind of cities do we actually get to see, in 2050 or something like that. Do we actually get to see flying cars and something like we saw in Jetsons when we were young? Or I don't know, will it be something even more crazier and even more fanciful? So while our creative juices are flowing, let's just get on with the day. So for those who are joining right now, just to let you know that the IIDA Summit is an initiative by the Architect's Diary. It aims to bring about a stir in the architectural fraternity through insightful engagements with renowned and great minds in the field of architecture and design. There always has been sort of a competition between art and technology, where we constantly feel that either one of them is winning and one is lagging behind. But probably in real life, like we already stated yesterday, and actually even got life proof of that through a lot of lectures and workshops and and probably a panel discussion, that it's probably not that. That is not the reality. The reality is that art, architecture, and technology are kind of moving hand in hand to provide us, that is, provide the entire humanity with a better life, with a much more civilized lifestyle, with an elevated sense of living, if we may be able to call it. So obviously, from this you'll be able to understand that this is theme, as we all know, is reinventing design through technology. The partner of this event is Blendin, the ultimate mobile application for all use, that is art, architecture, and design from across the world. So, through this 2 day event, that is the day two is today, you will be able to attend all the different panel discussions, workshops, and sessions that will be happening today, which we have already gotten on board with. Just a few things that you might take note of, which actually might be helpful, is you can switch between auditorium 1 and auditorium 2 anytime you feel like. Actually, there is the entire schedule which is available in each of the auditoriums. You might want to download it in case you still don't have it, and might want to take note of all the lectures and all the panel discussions that you would like to attend, and make sure you don't miss them, because our architects and us for that matter are more than excited to converse with you, talk about art, architecture, technology, and altogether have a wonderful time. So during the last few minutes of any session, you can send in your questions and we would ask the designers to answer them on your behalf. So, as I said, you can definitely send in questions and we will try to give you prompt replies through the designer, through the architect, whoever is the speaker on board. You can also mail them in case you want to do it some minutes into the the whole lecture and everything. You can email them us to IIDA Summit @gmail.com. Please, of course, for a better experience, use your laptops to attend this particular IIDA Summit. Also, there is a network lounge, if you have observed, where you can actually network with all the participants and everybody who's present for the event, and actually again all together enjoy and have a great time at this day two IIDA Summit. So already we have, as I said, we have started off our day two on a very positive and a very inspiring note. So moving on, let's move on to something even more better and even more inspiring, something like hearing an architect speak, maybe absolutely live. Yeah, probably on live stream. That's something we might be looking forward to. So yes, we do have Mr. Badrinath Kaleru in the house who will be speaking to you. Mr. Badrinath Kaleru, a gold medalist from IIT Roorkee, founded Studio Ardete in 2010 with the belief that every problem has the capacity to inspire unique and creative solutions that motivate growth. His vision is to design spaces that would evolve into art, enriching the lives of the people inhabiting them. His work has been published on various national and international platforms, besides being shortlisted and awarded. So, we already have Mr. Badrinath in the house. So, I would like to welcome you, sir. Thank you so much for agreeing to be a part of the IIDA Summit 2.0. This day wouldn't have probably started on the amazing note it will be right now without you. So go ahead, please take the stage, and I think our audience is more than excited to hear you out. So please go forward, sir.
Thank you, Binita and IIDA for this opportunity for having me here. And let us get into understanding based on the context what we have, reinventing design through technology. So in this, I would like to start with how, why technology is is part and parcel of our life, and how does it actually impacts architecture per se. Because, for example, like there have been how the evolution has happened right from the first industrial revolution. So the whole, I'll just want to run you through how the perspective of architects has changed. Because when the first industrial revolution happened, in every industrial revolution, they say that like three things change completely. For example, the power, the source to power things, for example, energy, and transport, how the mobility happens, and communication. So all three together, when they change, it causes what we call as an industrial revolution. And after that, the world doesn't look like what it was before, and it is even difficult for people to actually imagine from a pre-industrial age to what would it change completely. For example, like in when we have seen that after the first industrial revolution, there was a complete shift in the economy, and wherein like the when coal was invented and transport, for example, like railroads were invented, the entire railroad network which happened, and telegram was the first, it was the change in communication. So that at that time, before that time, like architecture, the role of architects, like they were also like before the first industrial revolution, they used to be like master builders. They had this more, like we used to have a lot more responsibilities of actually building it up. And then when we actually moved from there, then the role of architects has, like at that time where they were supposed to be like they were building nations and everything, then it changed during the second industrial revolution. For example, when oil came into place, when oil was discovered, then roads, the entire cars, like for example for transport, the entire road network was created. It was a completely different way, like people, like buildings started needing parking, for example, which was never there in the first place. And communication, for example, from telegrams to telephone, it completely shifted the way people lived and imagined what life would be. So during that time also, during all this, like for example, even in the present, like there was a the third industrial revolution, where it talks about right now, like it says that we are also in an industrial revolution. So what is it changing right now, and why is it important to us? Because what is changing right now would create what the life would exist on this particular planet, like for the next 10, 20, 30 years, and for how it has been completely being changed. And why it is important to us? Because we are catering for, like what we are catering is to make spaces for human beings. And once the way that as a human beings, as a community, completely changes the way to look at things, and it would completely impact, for example, architecture per se. So everything in architecture is a function of what the available technology is. For example, how the energy is changing right now. So right now we are in a industrial revolution where we the for the first time in the history, people have started producing power. I mean, like when, for example, energies traditionally were created in bigger factories and transported to people. Now, to a point where you can put your own solar panels and create your own energy. So, all to expand that when so people are creating what putting the planet with entire solar systems. So, the whole concept of making an energy and transporting to people is gone. So, this opens up a completely different perspective of how the future would be. And similarly, when we talk about transport nowadays, with the advent of we are now in a stage where we are looking at driverless autonomous vehicles. So driverless autonomous vehicles completely would change how a car would have been imagined for the last 100 years, because the whole 100 years the car was primarily kept in a perspective of having it with respect to a driver as the center of it. But now, today, when there is no driver, the whole concept of owning the car also is completely questionable. It is even possible that we would make buildings 20 years down the line without the need of having parkings per se. And even how the communication is completely being changed in terms of with the advent of like the like we are looking into a world where it is completely like we are edging into metaverse and in a completely new way how we could communicate with people as it was not possible before. So here are examples that are around us, what are happening right now. For example, recently, like Mario Cucinella Architects and Wasp actually created this completely made with earth kind of 3D printed buildings, and even like how it could even be built into steel, and like how it happened in Amsterdam. So in this particular possibility where technology is like aiding and we're creating something which was not done before. So how I would also run you through like how as a practice we have been able to create something with the technology which we were being unable to do it probably in a different time. So for example, the first project I would want to talk about is the ribbon house. So ribbon house is made in concrete. It has this like the whole idea is like the spaces are like caved into this set of concrete ribbons, and how it shapes into the spaces and how it creates this kind of soft spaces. So this, for example, is not a 3D printed building. It's completely made out of hand. But yes, it has a lot of like, because of the technology being aided into it, we could create what we could not have created possibly. For example, first thing was the design communication. It's not that we could not create these designs before, but how do we communicate these kind of designs to people who are working on hand and doesn't have experience on looking at these technologies to actually physically understand it. So for that, during the initial meetings we actually had a full scale 3D printed model for made out of it, wherein we could communicate that what we actually wanted it out of it and how the spaces need to exist, and that gave them access. And the other way of communication was probably earlier like from drawings to models which can be accessed and referred to at site, where it gives you lot more information and constantly changing information, so that it provides them the tools to build it. Because probably curves and these kind of fluid surfaces, when they are challenging, yes, but they are challenging to build on a factory, and even more challenging to build on a site, and it is even more challenging to build with people who are not experienced to build with it. So the kind of casting, shuttering that needs to be done for it, the framework that needs to be done for it, and how this reinforcement has to be done, so it completely changes the way like we could have worked earlier. So these are some of the examples of how like how the surface moves in smoothly. And for this, like when there is a manual intervention, like what was supposed to be made like what was supposed to be made like with human, because buildings probably are the last things that would still exist that would be made with hands per se. So to create those kind of curves in a real sense, and to actually check the rightness of it, probably like we certain times used like AR based objects where we could really scale up and look at it, that are we what we were making, was it in sync with what was the initially proposed. So it has this gentle curves that flow into it, and even the staircase. So many a times I don't talk not just about like the parametricism or what we talk about the fluid based architecture in terms of the technology that is available, because technology even for any kind of form making or any kind of architecture which was not possible earlier, so with the help of technology, like here even like in this also like how we could convert a model into a physical object wherein like all the curves have been taken care of. And this, for example, staircase, here we used components which were precast. So for example, the steps were precast onto a model, and then we have got onto it and then parametrically tied them up to form like a net structure. And the bottom few steps we have converted them into a bar, wherein like it reaches where the staircase reaches to the bottom, it converts into a bar. And this flowingness of it was which would have been earlier being not possible, but because of the available, like how we could communicate in terms of visualization methods, like we use virtual reality to actually communicate with the clients and the stakeholders at how we could create this. And this, for example, to be made on site, it makes a lot more things easier. Like it would have been lot difficult to make if either it would have been made completely by hand. So for this was another example where we use assistance of computer aided manufacturing to create these kind of ribbons, but still these were made with hand. So we're talking of an example where the sections were not completely made in factory, because this is a veneer store, and this has been like hand pasted with veneers, this entire structure. And this in this like what to create this kind of space where it is free flowing. So we used a system where we could it's a simple like a puzzle based system where we could slice through with machines, where with CNC machines we could completely slice through with at every sections of every intervals of around 75 to 100 where we could slice through them. And we created like a zigzag puzzle, and each one was individually numbered, and they were engraved on at the stage of manufacturing the individual section as well. So at that time when we started, so the person at site had just had to read through them and then just start stitching into it. And then by section we could create it. Then we could wrap it up around with a very thin kind of a veneer surface which can be cladded onto it like seamlessly. So this was when we were working on it initially. So this was a 3D model that was made for it. The whole idea was the purpose why it was made for what it is was like it was a veneer store, and we wanted to show the whole experience of what the best possibilities of veneer it could be. So there's an way place where we could see one element which was forming what we call as a ceiling. It forms a console, it forms a sitting, and it even forms a table. So this one single ribbon that moves all over the place. And so at the communication step, like initially while modeling, yes, these have been this was like, for example, this was sketched onto it, and then we used softwares like rhinoceros and grasshoppers to create the smooth surfaces, and then like slice through them to make it for the drawings for the factory. And then they come back into puzzle, and then the handwork which has to be done on top of it by the veneering and everything. So it is more like it assisted the kind of possibility which would have otherwise been like not possible, right from the conceptualization to get it for through communication, and at the same time to get it to on site to execution. So this was another structure where we used so basically we used different set of scaled models 3D printed to calculate the kind of stresses which we are having at the edge of the beam. So it helped the structural consultant to understand how it was, because when we gave the initial concept to them, so it was difficult for them to actually visualize that what exactly we're trying to do. Then with the models and with the kind of communication, it became a lot more easier. So this kind of, and even for example, the kind of angles to be executed on site with the kind of like HoloLens kind of technologies where we could see through it, like where are we there, or are there certain things that needs to be shifted into. And so this is was an a project that we did like around 5 6 years ago, and this was a facade that was made for a commercial building. And this facade here, we initially we were developing sort of free flowing typologies, because the idea was like this building was in an setup where it was an emerging part of it, and we are looking to make something that was to resist back the main structure to, because it was a west facing thing. We had to cut through the heat. And we were using, because it was a tight budgeted project, so we weren't using high spec glasses, so we were finding a way where we could create some sort of an element which could wrap around the entire surface. So when it was done in 3 inches thick concrete, and for the kind of perforations here, so there was a lot of initial idea, like, okay, when we started typology, and then when we started sketching it out, and then we map when we looked at created perforations within, like, by using programs where we could reduce the number of polygons, remove the surfaces. And still again, like, when though there is parametricism there, it has to do with lot the human intuition element, which cannot be completely eliminated, because that's how, like, we are, like, the humans design are smarter than, like, or the way we look at things are very different, because the whole human element, that where we could capture those views, where we can keep that thing flowing, how could we let the greenery come through it. So these were, like, right from the initial sketches, the intent was there, and that could be translated so by using technologies. But yes, but at the core of it, it needs to exist in form of an idea which has to be manifested into it. Because end of the day, we talk about AI, where computers are creating artwork and architecture. But what if it misses out onto the human intuition or the human element? Because end of the day, probably, like, the whole aspect of architecture has to do with more with humans than with anything else. So, like, as architects, though we are technologists, we are technicians, we are engineers, but we need to be, like, it has to be, it's more human than anything else. So then the whole aspect of human changes this completely. So this was a project where we did it for a school, and it was in the it was on the main highway, where we were looking at having a, this was an extension block. So the whole idea was how we could create a playfulness around what the experience of arrival could be. So this entire thing, because it was for a school, we wanted to bring in out that playfulness. So this was made with simple curved surfaces, because in terms of the initial thought, it was more complicated, which was more curved. But to we had to work with the available budgets, and this was being made in, like, one of a very remote places, which was very far away from, so the kind of infrastructure availability. So end of the day, it was supposed to be made with all by hands and with very minimal tools and appliances. So for that, like, then we had to rework the curves into simple curves, from, per se, with from parametric curves to simpler curves, and to simpler arc curves, which were easily achievable and maintainable at sites. So many a times, we also have to evaluate the possibilities of design to possibilities of what could be executed, and how we could still work with the intent that was there initially. So that was how we could create this kind of playful thing. This was an very initial project, where we had this a parametric roof, where we could literally, like, give each particular with the surface, calculate what would be the lengths of the rods that has to be done. So it was completely calculated by the software, where we could give them that individual, like, a list of the rods with codes, and what height it needs to be placed with. So which was, again, like, which in a manual process would have been completely, like, not possible to do it. These are other examples where we could use curves and could create something that was really, like, interesting. So where are we headed to? For example, in the present situation, like, where we are looking at complete, like, 3D printing to a point where it could be completely replaced the manual labor, and probably, like, how the entire concept has been completely changing. Probably, like, there would be a possibility, like, in the future, where we talk about, okay, robots building places. So it could not be like, the current kind of disruptions that are happening. it would completely change the way how spaces would be, what we have been thinking. Probably it would be more like how we have seen in Star Wars, or like how kind of those sci-fi movies. Because end of the day, the whole idea of the the frame structures, or like what was the idea of the domino system, was primarily based on the understanding of structure and the available technology. And once we work with materials which they don't need any kind of supporting structure for casting per se, like how concrete needs to a surface to be casted into, a mold that is to be casted into, to a point where they are just deposited, like in how 3D printing happens. So it completely would change the way we are looking at spaces. Probably more optimized spaces would, like, we would completely get rid of straight edges, or probably angular edges, which would be based on the materials we have today. So the future materials would completely change in the way that the fluidity of forms that would happen, where, because the whole idea of incremental deposition, which is how the 3D printing works, which could make buildings like more closer to nature, probably because nature also builds step by step, and probably that could be one possibility. And in terms of like AI, there could be a significant significant understanding or movement in terms of um elements which we don't process them at the same time simultaneously. Like now we have like the whole idea of having now we have so many consultants onto projects. So then with this AI, though, like it could be possible, that there could be a segment of people building like homes, or completely without the need of a human architect. So if there would be AI architects, which, so what if like you could create like AI architect out of probably like what was Zahadi doing, like the entire thing what she was doing, if you can make it learn to a machine and to create something that was there. So probably we could have an AI Frank Lloyd Wright or AI Lee Corbusier, which would change the way we look at things completely. And in terms of like how mass production has been changing, so like even in certain countries, people still, they can book their houses and they come in a box and they can open it up. So where things would be like when we where people can actually build their homes themselves to offices. So the way how it would affect the entire thing would be like, even though understanding technology has been like one of the biggest things that architects have been adapting to, because everything what we consider as what it is, the best possible thing for anything, would probably be only be valid with that given technology. Because a design can only exist when the design optimization works only best when the technology is stagnant. Once the technology changes, the parameters of design completely change. So that way, like how we, like for example, there is an example where we were doing a huge installation for an indoor environment, and we were working with an artist who was based out of Poland. So to work with an artist and an architect together, so we were creating a installation which was done together, and it was being a huge humanoid sculpture. So for that, there have been like for example, the artist was working on smaller models. We could scan them and then scale it up into the huge spaces, and then we redesign them as per the space and keeping the artist intent, and to change completely into something that was different. And that particular object, when we discussed through the artist, which was again which was completely changed in 3D, was printed onto a real object, and then the artist had that as an input to create what was finally created. So this help that technology has given has also increased in terms of the collaborative effort for various design professionals, because art being a very subjective and very individualistic thing, can now be something where there could be multiple professionals involved into it, and where they could still create, communicate. And even the whole aspect of the metaverse, how it is shaping into, where we now also completely eliminated the physical possibilities of materials, the physical possibilities of gravity, to completely virtual environments. And that would would probably be like probably a different way. Like even I'm not sure how architects would exist in the future per se. Like they wouldn't be like looking like the way like how they are today, or it would need a different kind of understanding and different kinds of understanding of technology. For example, like how architecture was taught would completely change, and how the future architects would be, it would completely change the way how it could be existing. So for example, like certain things which we thought would be possible, like in terms of in the changing aspect of technology, as architects what we need to look at, and I would perspective is like we need to probably uh, unlearn few things probably which we have like learned, and probably look at new ways. For example, like building, like already like there have been now buildings, like there have been cases where people started stopped building for the program, because the program itself is changing and it changes for the span of the entire building. So now the whole aspect of building for functionality has moved to building for all the future possibility, as is a new perspective where we could look at it. And at the same time, when because with this technology there could also give access to the materials which were used earlier but which were considered good but didn't had the kind of like didn't sustain for the 19th or 20th century. For example, lime per se was, which was the widest building material probably couple of centuries back, and now today it's like totally been replaced by its new like cousin, or the concrete what we say. So there could be, but still we know that the better possibilities for lime, and how the properties are still intact or good. So there could be possibilities with technology where we can bring back like sustainable materials which were used for earlier generations, but because of the fast paced shift of the population or the possibilities which we wanted, those have been eliminated from the mainstream construction. So with that, or with this kind of new technologies, they could be brought back into mainstream technologies. So this is one thing which I would be like probably excited, which in terms of to see how we could bring back new materials or new possibilities and find new technologies. Because end of the day, when technologies evolve, it needs certain time and understanding to convert them into what is really purposeful and useful. Because technology initially, like it might be exciting, but many a times that it needs certain kind of wisdom to actually reach to a point where we say that the technology would be helpful in the way that it could actually create impact for people. So with this I conclude my presentation. I'm open for questions or whatever.
Thank you so much, Mr. Badrinath. We couldn't be more enlightened with, actually, again, since yesterday we have been, but this is again altogether, like you spoke about, an altogether different perspective that we got to know about. And yes, we will be getting a few questions. It usually takes a little bit for the questions to pop up. Meanwhile, if you don't mind, I had a few things going on in my head while you were delivering your thing. So maybe I could just start with that. So as obviously we know that Studio Ardete has been very what should I say, into the whole concept of, let me say, idealistic and innovative facade designing, right, with the, of course, with the encryption of technology. So if I have to tell you which was one of the most challenging facades that you envisioned and actually got to implement it? Because a lot of times, new architects do complain that even if we think big, it doesn't get implemented. So I genuinely want to know, sir, which was that one facade or one design for that matter that you really envisioned in a very futuristic or a really challenging manner, and actually still could go through it, and how did you do it? So if you could just tell us about that.
So basically, like when like what normally when we visualize it, and we always like we look at possible. For example, Never Never Cube, when it was made, we had quite a few challenges for getting it done in terms of. So we actually for a certain kind of thing. So usually we need to work with the contractors to actually get to a point that what would be the possible challenges of executing it, because usually when we used to do initial years, so we didn't we like, because as architects we always live in a virtual zone, like okay, for creativity possibility, but at the same time reality also needs to be part of that particular possibility. So when we were working, so for Never Never Cube, so it was like uh, quite challenging in terms of that when we first said okay, we need to rest, everything would be hanging onto it and it will be of a facade. So it was like even the structural consultant was like a bit skeptical about what we could be possibly done. But yes, like so more of often than not, the challenges is about how we actually could find the right way of executing it, because that is very critical. Because yes, you can you can build this same facades and spend up double the money. So and that most of the time would completely change the way the economics, because we already push our boundaries to the maximum possibilities of the project budgets. And when we are at that particular range, and then if there is an there's a facade that needs to be executed, and which would we are spending double the money, and that's where probably like the stakeholders would not be much interested, and somewhere we would miss the whole point of it. So for that, we actually sit with it with the like the contractors and the execution team, if we could find the trick to execute it. So in Never Never Cube, it's actually just one mold that was repeated, twisted, turned, and so we made one entire die for a shuttering for one particular box, and we just keep repeating them. So which saved, like for example, it was complicated, but in a way it was modular. So and there was certain element which was not like casted, that was flowing into it. So with that, and it completely changed. So for example, even for the ribbon house, it was quite a challenge to actually keep that curves in place, and certain times it was really pushing the boundaries, and a couple of times the curves didn't get right, so we had to literally like rip some part of it. So that was like ribbon house and Never Never Cube are a couple of things which are.
Okay, so we have one question that has popped up. So, is it imperative to study the form of the design that would take by using 3D printed technology? Yeah, that's the question that has been popped. So,
So, for example, when we so if the question is about the study, the form of the design by, so when we talk about 3D printed technology, so for example, we have been using prototyping our facades and quite a lot of it for quite some time. So in that, like the whole idea is like when we initially, so the communication part gets much clearer in a 3D printing. So yes, for an as an architect's perspective, you can understand real scales and real sizes and everything, but the same visualization, you don't have it for the stakeholder who has to take a decision. So that becomes a very, because many a times, like when we the 3D printing would help in certain objects, like for example, when they are curvaceous surfaces, it helps a lot, because even there are other tools of modeling, but this additive would get you much closer to it. And yes, understanding it from that perspective, for example, where you're in the space, for example, when we are looking at when we made a project for that the veneer store timber rhyme, so it was like we had to actually show him that how this entire thing, because looking at the 3D, the client was like, I don't understand anything of it what you're showing. So then we actually put it to a real scale, and understand that how these things would blend into it and how they used into it. So that helps a lot in communication.
Hmm.
And even we use it,
Oh,
like for example, in some places we use it like as a replacement of drawings, because if it is complicated enough, so it needs, for example, the drawing would need information, probably 100 pieces of information. That 100 pieces of information can completely be eliminated by a scaled 3D model.
right. Okay, so another question has popped up. How efficient is it to optimize? No, actually, sorry, there's a little note as well, which I should read out, I guess. Awesome presentation. How about optimization? How efficient is it to optimize and not compromise the shape of the building? That's interesting, I think.
So again, when we talk about optimizing, because so what happens is like when we talk about a certain possibility of a form or a particular thing, so it that's where, like when it the first thing that is needs to be happen, that it needs to exist in a real world. So when it needs to exist in a real world, we have to see what are the possible ways of getting it right. For example, if we look at like how Zaha's initial days work, most of it is still unbuilt work. So it was that things would happen where like the technology goes much fast than the reality, or in terms of reality, not just in terms of it can't be built, but it can't be built to a viable solution. Like to build it, for example, I myself worked in with Jean Michel Wilmot. So there have been so many competitions wherein like wherein the competition was won by ZHA, but
Hmm.
the work was given to the second prize winner, Wilmot Architects, because though they have won the competition, that's the best possible design. But the company which they say we can't afford to build that particular design, and even that we what we saw in the Tokyo Olympic, how the midway they had to change an architect to do it. So here, the distinction which we need to look at it is that end of the day there's an intent, and that intent has to become reality. And like it becomes even more challenging for architects like us when we talk about projects where clients have a fixed set of budgets, and we have to deal through it. We are not talking with giant corporates where they can think or raise funds for it, but they are individual homeowners or individual school owners or like individual people. So for that, we it's not that we can't change it completely, so we need to find possible solutions. So most of the time, rather than starting off from a design board, we would start from a real world, see what possibilities are there, and then what best the design is possible. So for example, if when we are doing hexalays, my parameter was consideration was I had a very good civil contractor who could execute what I was doing it, and the building was built at a budget where I don't have access to claddings which are possible. So I need to have that material which is being used for construction as a cladding and still create something meaningful out of it. So those parameters which come from the feedback comes from real world are far more valuable to actually process the entire design, because designs can be processed. There would so many be designs that could exist in a virtual world, like we have those filled with Instagram and Pinterest. What does it take them to get into a real world, to bring it to a real context, into a real thing? That makes all the difference.
Right. So, but just the one bit I think that I really liked, and I wish somebody had told it to me while I was a student. The thing that you said, that sometimes you can. It's not always A to Z. Sometimes you can go from Z to A if that's what it takes. That's something that I think is a very practical solution to a lot of things that architects face in real time. Okay, we have another question that has popped up. How did the load transfer of the parametric structure happen in the ribbon house?
So end of the day,
Very.
though, so for example, it works similarly. Like for example, for if you look at the Toyo Ito's Taichung Convention Center, where they have arches made out of reinforcements. But here we didn't weld them up. But yes, it works onto the similar principle where it needs that kind of flying buttresses to hold up the entire thing. So these are again analyzed computers based on the structural engineers, where the better possibilities. And here, what happens is when we have an an idea that has to be executed. Many a times that if there was a solution, but that solution tweaked up 10% would make a lot of 90% structural sense. So that is what, for example, when we did ribbon house, there were certain things. For example, there was a certain column that was being terminated at the ground floor, and then we had to uh, then the structure was such that we had to have in a completely space which was completely without any column, which was quite difficult to achieve. And it was like so the structuralist said no. So then we had to go back to our drawing board and see that how we could include that particular column into the design and still keep the intent intact. So that is the thing that is more important than the initial concept, because initial concept you can go haywire and understand what it is, but ultimately once you don't put in like all the sense that is prevailing in terms of the structure, in terms of services into it, then it becomes a big ask, like for nothing. Because whatever becomes justified, if it can only be justified when it is completely structurally sound. And for example, building these kind of structures like this is built in earthquake zone 4, so this is a lot more challenging probably if I do the same thing in Jaipur or in, for example, in Mumbai or Hyderabad, which predominantly are in zone 2. So building them in zone 4 gives you it needs more kind of reinforcement, or codes and everything gives you more challenges.
Okay, I guess that's about it. So thank you so much, Mr. Badrinath. It was a really interesting session. It was really cool to see your work and the stuff that you guys are actually putting forward. And left, since yesterday we are being odd, and I think we are reaching a point where we think that, oh, now I don't think we'll see much that will be owing. But every next architect comes and presents such futuristic ideas that are absolutely throws us into a different level of awe altogether. So yeah, definitely it was really inspiring, very enlightening, and definitely very informative. Thank you again for agreeing to be a part of IIDA 2.0. We couldn't be happier, we couldn't be more informed than this. I mean, thank you so much, Mr. Badrinath.
Thank you, Benita, for hosting us, and thank you, IIDA, and thank you, Siddharth, for having us here, and thank you, the entire team of Arctic State.
Okay. Okay, guys. So with that, we come to the end of this part of the session, but we will be resuming again at 2 p.m. So please do come back and don't leave, because if you choose not to join in, you might be missing out on some more, as I said, awe-inspiring conversations and designs and ideas that were probably that probably share way varied perspectives than we could ever imagine in this current date. So stay tuned, come back at 2 p.m. Let's join again for some more video conversations, panel discussions, and everything that is there in store for you. So, hope to see you back at 2.